Right, thank you very much. Thank you for having me here at DjangoCon. My name is Rudi. I'm a principal engineer at an organization called Reach. I've been at Reach for the past 8 years, writing open source software using Python and Django. I want to give you a quick overview of who we are, what kind of projects we do, to give you kind of some background information, some context around the more technical things, which I'll delve into in a bit. So Reach is a non-profit organization based in South Africa that uses existing technology to improve healthcare and to create social impact. So what do we mean by existing technology? These are things like, this is technology that our users already have in their hands, things that they're already using and already familiar with. We're talking about things like SMS, USSD, WhatsApp, and sometimes on occasion web as well. But we still use Django, even though web is a small part of what we do. By saying improving healthcare, we're focusing on lowering the barriers to access to healthcare, as well as supporting the health systems that are providing these health services to our users. When we talk about innovation, we are using old existing technologies, but we innovate in the way that we use these technologies in new and interesting ways. I'm going to go over some examples of projects we use to give you some more concrete examples. In South Africa, we have a service called Mom Connect. It started off over USSD and SMS, later on expanded to WhatsApp. The way the service works is pregnant mothers would go to, when they register at a clinic, they can get registered to the service. It then sends them messaging with relevant information to their pregnancy according to the stage of pregnancy that they are in. So it's specific tailored content relevant to their stage of pregnancy. This is things like, the clinic should be giving you iron pills to take at this stage, or your baby is now the size of an apple. Or your next clinic appointment is due soon. It also gives them access to a help desk staffed by nurses where they can ask any questions about the content or any questions they have in general about their pregnancy. Another project we worked on in South Africa was Young Africa Live. This was a WhatsApp service. It's designed to empower young people to explore and embrace their sexuality and make informed decisions on their health and well-being. This is one of the first services where we looked at doing tailoring and segmentation, having a look at how we can customize the service to better serve their specific circumstances. Another project was Men Connect. This was also on USSD, SMS, and WhatsApp. This was to deal with antiretroviral treatment initiation and adherence for men living with HIV. So what can we do over just text messaging in order to help people initiate the drugs and also then adhere and keep taking those drugs throughout their lives. And yes, so another project, the one I'm going to be focusing a bit more on this talk, is Contact NDOH. To set the scene, this was near the start of the pandemic. This is when we were having lockdowns come into place. There was a lot of misinformation going around. A lot of this was happening on WhatsApp. So we wanted to do something to help get proper information out there. We partnershipped with our sister company, Turn.io, to create a South African National Department of Health WhatsApp service. So this is their service, which we implemented. It started off being a technologically very simple service. It was keyword-based. You you send in hi, you get this little menu thing, you send in myths, we send the thing. So technologically, it was fairly simple. We did this so it could be quick to get up and running and easily handle large traffic volumes. And this is the service where we ended up with 14.9 million users. So after we had this up and running, we were getting this evidence-based, up-to-date information to people. We started to think about what can we do that's a bit more advanced. You know, there's quite a big limitation on the system that we're putting in there. So what can we do now that we have a bit more time, a bit more flexibility? So at the time, not everyone could get tested for COVID-19. There weren't enough tests. So there were guidelines about who can get tested, but these were often quite complicated, confusing. They were changing often, and no one really knew what was happening. So we created a service called Health Check on the Contact N2H platform. We worked together with the National Institute of Communicable Diseases in South Africa to develop and then later on updated as new information came in, as things changed, on what you should do. You know, let's ask you some questions about your symptoms, how you're feeling, and using that, create a risk classification algorithm to let you know, okay, you need to go in for a test now, or you need to isolate for a week, or no, you're actually fine, carry on as you were. So as part of this, the National Department of Health wanted to integrate this into their data lake. This is to help them detect any hotspots and to redirect resources in any areas, as well as to gain any sort of insights that they wanted to know about symptoms and how they were spreading across the country. So as you can see, this is a lot more complex system to implement. We need somewhere to be able to store all these results, all this data, and also be able to surface this for the NDH data lake team to be able to pull this into their system and then run analysis to this. So, of course, Django to the rescue. This seems like a very simple thing, right? We take Django and put a Postgres backend to store the data. We use Django REST framework to create the APIs that we need, and everything works well, right? Well, until you hit lots and lots of rows in your database, and things start becoming a bit unhappy. This was a very interesting project for me. It was one morning, I was looking at the packaging on the loaf of bread I was eating for breakfast, and I saw an advert for my service, the service I was working on there. That's quite cool. It's never really had a project like that. Most of our things are just advertised inside clinics. So to see it being advertised on TV, even on the loaf of bread I was eating, this was a big service across the country, and we had lots of users trying to interact with it. So what is the one thing that you should never do on a really large Postgres table? Well, count star on the whole table. There's a whole page of that in the Postgres documentation. It will lead to a very slow query and be very unhappy. So, of course, your Django admin page, when you're viewing all these things, of course, it does a count star, but it doesn't only do a count star, it does 2 count stars in order to generate that page. So how can we get rid of these? Well, the first one is fairly easy. The first one is due to when you select all the objects, it shows a little thing up there saying you've selected 100 objects, there are 1,000 objects total, do you want to select all of them? It uses a count to get how many total objects you have in there. There's an easy config in your admin model there. You can do the show full result count equals to false, and then it just says show all instead of show a certain amount of number. So that one was easy to fix, but we still got one more. That one is a bit more difficult. This one is related to the pagination, which is unfortunately not something that we can easily change in the Django admin. Django admin uses page-based pagination. It puts the page numbers at the bottom. We don't really want to change the whole thing. That's a lot of work. So how can we get around this? Well, we can create a custom pagination class. Unfortunately, that class doesn't allow us to completely change the way pagination works, but we can, Postgres offers a method, a way to get an approximate count instead of doing the full count on the table using statistics that it gathers on there. So for these really large these really large tables, we don't really care to get an exact count. We're not going to want to navigate to exactly the 103,000th page of results. We want to use the Django admin in other ways, but but we're unfortunately stuck with this pagination. So we can use this count estimate to really give Django something that's close-ish, so it can generate its page numbers and things, but still allow us to not have to do the count on the entire table. So this is how we could implement something like this in our custom pagination class using Postgres. This will just give us an approximate count. But what if we don't want to do this on every table? What if we want to make a generic thing that we can use everywhere? Because we can do better than just getting the approximation. What if this table starts off small, gets large? What if in some cases we don't want to always have this approximation, which can be quite wrong for small numbers? Well, what we can do is we can set a timeout on the SQL query in Postgres. What this allows us to do is we try to do a count on the whole table. If that starts taking too long, we can then cancel that and carry on with our approximation. So we can put these two things together inside our custom pagination class. We go through, we try to do a count of the whole table. If that takes too long, we can then return the approximate count of the table instead. And that solves the two counts that Django admin does and makes our admin page responsive again. We can use it. Great. Next, I'm going to talk about how we designed the API with Django REST framework. Now, we can't return all the results in a single request. That would be a massive request, take forever. We don't want that. What we want to do is have some sort of pagination, return a page of results and a way to get the other pages of results. Django REST framework has a few built-in options. It does the page number pagination, similar to what Django admin does. Obviously, you can't use that. There's a limit offset, which also uses count, so we can't use that. Finally, there is cursor pagination, which it offers. This is the one you want for really large tables. It has some downsides. You can't navigate to an arbitrary position. In the data set, you make your query, you get the first page, you get a way to get to the next page, and to get to the 10th page, you have to go through 10 pages. But for our use case, that's not really an issue. We have an index on the timestamp field of when these things were inserted, so if you want part of the data set, you just say, give me everything from this timestamp onwards. Very important to have an index on the ordering field you're using, because that is how this pagination works. In order to create the pages, it's important to be able to very efficiently order and go to a specific part of whatever your ordering field is there. Following on, you might have noticed that I've missed a part of this. I've gone straight to the solution here of what the problem was and how we fixed it. But how did we find that? How do you find where the problem is in your system and how to improve that and how to fix it? So the first important thing is you need to measure before making any changes. You need to have a setup where you can go through, test, and make sure you know that the changes you're doing has the desired effect that you want. It's making things better, not worse. You're not doing extra things and it has no result. So the first step of that is that you want to be able to have a test set of data in your database. If you're running these tests on an empty database, you're not going to get the same results as in production. So for this, if you use if you can use a copy of your production database, great, that works. But oftentimes you can't. Maybe this is before you have any data in your production database. You want to make sure things will hold up, or it contains confidential information that you can't put in your testing environment. For this, I found using a library called Faker works really well. This allows us to generate realistic looking but fake data to put in our database services. It allows us to define things just simply in Python, and it can generate as a wide range of different data types that we can use to generate the realistic looking data without actually using our production data. The next step is now we need to put some sort of load on the system. We have the fake data, now we need fake users using our system, and so we can see how that works. Tool that's great for this that we've used is called Locust. This allows us to do quite nice load testing on the system. You can do fairly complicated user flows with it, and then you can see exactly what endpoints are slow, where do you need to focus your time and energy at improving the system, what are the bottlenecks that you have there. Similarly to Faker, you can define it just using normal Python, where you can interact with the APIs to make requests against yours. And you just describe your user journeys, you describe how often, how likely each of the user journeys will happen, and it will go and execute those and run around with your fake users. Now that you've determined where the problem might be, this view or this endpoint is very slow under load. Now you want to know why is this slow under load. Dig deep into that. One of the most useful tools I've found is quite a popular tool. It's called Django Debug Toolbar. You navigate to a page, it will give you so much information about everything that was used to create this page. And the most important thing is it shows all the SQL queries needed to generate this page. So this is, and the time it took each of those SQL queries. So this is where you can see, my Django admin is doing 2 count stars, and that's why it's slow. Or, this query is very slow. We should look at putting an index on this field to help it out. So this really helps you to delve deep into those things. And now, nearing to the end, I just want to go over a few more odds and ends, a few more tools that kind of really helped us. You can use Django Debug Toolbar, or if you're in debug mode, you can use the connection.queries. That will give you the SQL queries that are running, so you can see what is the actual SQL queries that are running. If you put an explain analyze in front of that and send that to your Postgres database, it will tell you exactly what the query planner will do, what it's doing, what parts of the query are taking long. That really helps you to find out which fields might need indexes, or where you can really change your queries, change how you're making your queries to improve them. But of course, always make sure you're running this on a database that is full of data to get realistic results. If you have the query set, you can just call .explain on it as well, which does the same thing, much easier. Then, as part of the Django kind of testing framework, there's the assert num queries assertion. This is really useful. You can put it in your unit tests after when you run your view, and it will assert that you only make a certain number of database queries. This can help you catch any of those annoying N+1 issues on your views. It can also ensure that if someone comes along, changes a critical view, which makes it make another query or more queries, this test will then fail, and you can go and have a look and make sure that you're not going to run those performance tests, make sure that this change is not going to slow things down, and this release make your service worse. Another one is PyPy. It's very compatible nowadays with a lot of libraries and compatible with Django. And simply by running your things on PyPy, you can get a nice performance boost. Not always, so check with your benchmarks that you've set up now. Make sure that it actually does, but often or not, it can just give you free performance, so that's nice. The next one is logmin duration statement. So config in Postgres. You set this to a certain value, and Postgres will log any queries that take longer than this. So you can put this in your production, and then any queries that are taking a long time, you'll immediately be able to see those in your logs, hopefully somehow trace that back to your application, what is making those queries, and figure out. If not, it gives you a good idea of where you might need some indexes on your tables. Last one, I want to give a shout out to pythonspeed.com. I've spoken a lot here about SQL and optimizing SQL queries for your service, but what if you have a CPU bottleneck or memory bottleneck? Mostly Django apps are the database is your limiting factor, but maybe it is a CPU or memory bottleneck. How do you measure that? How do you find out where in your code is causing that slow? There are many great articles on there to kind of help you with that. And there's also a great article on configuring GUnicorn if you're using it inside of Docker. So if you're doing that, I can highly recommend that for performance analysis and reasons. All right, thank you very much.
This was such a fascinating talk on multiple levels. For me, what I really enjoyed was that this is very practical, very hands-on. And there's another thing going on through my mind, like when you mentioned that you saw, the advertising for the service on the bread, I got the goosebumps because I realized that by making this app available, by making sure it stays up and running, during the pandemic, but also during other events, if you see someone who saved a person from fire or another dangerous situation, it's a front page material. But even if you are very conservative with estimates, even if 1 in 10,000 users was saved because of this application, there's hundreds of people whom your application might have saved. And that's why I realized that in this room, there's a number of us, a number of you working on applications like this that, when they worked during the pandemic, when they worked during other times, that actually saved people's lives or affected them very positively. And I don't know if you think of yourselves like heroes, but you are true heroes, saving hundreds of people. You're not front page material, but this is huge.
Thank you. We have some time for questions?
Yes, we have some time for questions, and there are some microphones on the left and on the right, and if you'd like to ask a question, you can also raise your hand if you're in the audience.
Thank you, Rudi. That was really interesting. I'd like to know how you felt knowing that you were delivering this critical healthcare information and interaction to millions of people urgently in a crisis over a platform owned by one of the most unreliable and dangerous companies that's Facebook out there on the internet, in effect. That it's not really a safe infrastructure. You're at the whim of, or were you at the whim of WhatsApp and Facebook to do the right thing?
Yes, so this is obviously a difficult thing to kind of think about because we want to get it in the hands of people. We want it to be easy to use, and WhatsApp is such a great tool for that. And we've been working with WhatsApp since before they were acquired by Facebook, and working with them to beta test and develop their API, allow people to kind of run services over it. But yes, there is a bit of difficulty there. You know, we're dealing with sensitive health information, but also we're dealing with WhatsApp and Facebook. And there is a bit of security there in that WhatsApp is end-to-end encrypted. The message is decrypted on the user's phone, and then on our side is decrypted only by our sister company, Turn.io, which is a trusted entity to us. So they run the decryption kind of side of Facebook's infrastructure there. But yes, you do need to have a level of trust of that, because these are black boxes that Facebook kind of hands you to run and says these will decrypt your messages and send it to you. There's some trust that the app isn't doing anything strange once the data is decrypted on the phone. But I think it's difficult, but you have to kind of weigh out the advantages of that and advantages of using these platforms. This was also available. Some parts of it was available over USSD and SMS, which is even less reliable. Now you're trusting your mobile network operators. You're sending these things over plain text. It's not end-to-end encrypted. So what is better? There's no matter what medium you're using, unless I guess web is you can trust a bit more. But yeah, with these convenient kind of channels to communicate with the users, there's some trade-offs, and you have to trust at some point and kind of do your best to keep their data and information safe.
Do we have more questions in the audience? Please.
I just want to thank you for the talk. And how do you manage the locus with foreign keys and complicated patterns? I know it's a specific question, but that was very interesting. Thanks.
So, yes, with Locust, for us, using foreign keys wasn't that difficult, but what you can do is define your user journey such that the user creates this thing, and then a part of that you'll get a response which has the foreign key, and then you can use that for the next steps of your user's interaction. So you don't need to hard code these foreign keys in. Sometimes there will be some hard coding if you're saying needing to test a specific a specific article or page, or maybe selecting randomly from a list, and you kind of hope that all of these are relatively similar to have a relatively similar cost to generate. But yeah, it can be a bit difficult, but just try and simulate what a user would do in that, and a user wouldn't know what the foreign keys are, what the primary keys are of the thing. They just interact with your service and try to use that.
2 more questions, please.
You showed the Django debug toolbar, and in my experience, it's a great tool, but it tends to be a little bit slow. Do you have a solution for this, or do you just use other ways of finding the problem when you have slow view or something like this?
Yeah, so Django debug toolbar is not something that would obviously run in production. This is something run separately in an isolated test environment with the fake data. So for us, having it slow is not an issue. But I do know we didn't go over, there's a lot of tools for kind of sampling and profiling things in production. That Postgres configuration option to show slow queries is an example of one of those. And there's a lot of kind of tracing frameworks and tool sets that if you want to do this sort of thing in production without affecting performance, that is a way to do it. But yes, we stuck to using it in places where the speed didn't matter. We just wanted to, it doesn't matter, it takes 10 times longer to generate than in production, as long as it gives us the relative ratios of this is the part of the view that's slow and this is the part that's giving us issues.
Thanks.
And the final question, please.
Yeah, you mentioned locust and load testing.
Mm-hmm.
How do you make sure that you don't test the limits of your testing framework, or how do you generate this big of load because you have high availability and a very big system to handle those requests. Yeah.
Yes, so if you go in depth into Locust, it does have some things around that, creating I think they call it a Locust swarm, because Locust, where you can have multiple machines making requests. But yes, that's kind of an important thing to make sure that you have a target of, you want to load test so many users making so many requests per second. Make sure you're actually reaching that, and make sure that you're not being the server running the request is not being bogged down. That being said, Locust I found scales up pretty far before you have to do like multiple machine setup. It can take you pretty far with quite high loads, and most of the time it will be your servers. But obviously, as you said, if you're testing it on a large clustered setup where you can handle a lot of load, you're not just looking for where those pain points are. Yes, there are tools within Locust to kind of help you generate more load. But that's a good point. Make sure that you're actually reaching the targets that you want to reach on the loads.
Small follow-up then. Do you test against your production environment, or do you set up a separate one?
Set up a separate one. I guess you could, if you want to, test during a quiet time against your production environment. I prefer to keep things separate, test on a separate setup with a copy of the production database or generated fake data. I find that it could have some wins. It might be expensive to set up a whole separate thing, but I find that's worth it just for the kind of safety of not taking down your production system.
Thank you very much. Great talk. Thank you.